It is not possible or safe to rewire a 277 volts 3-phase 250 watt high pressure sodium or HPS ballast to operate on a 120 volt single phase electrical service. Here's why the voltage and phase configurations are critical factors in the operation of such ballasts and what could happen if you tried to make this conversion. The HPS ballast is designed to function with a very specific voltage and frequency. These parameters are determined by the internal components of the ballast, such as the transformer, the capacitor, and the inductor, which are all selected to operate optimally at 277 volts and with a 3-phase power supply. The purpose of the ballast is firstly to provide the initial high voltage surge necessary to ignite the HPS lamp, and secondly, to regulate the current flowing through the lamp during its operation. If you attempt to operate the ballast at a significantly different voltage like 120 volts instead of 277 volts, the internal components will not function as designed. The transformer, for example, is designed to step up the voltage from 277 volts to the much higher voltage needed to strike the arc within the HPS lamp. If you only supply 120 volts, the transformer may not be able to produce a sufficiently high voltage to ignite the lamp. The capacitor and the inductor are designed to work together to regulate the current at the specified voltage and frequency. Changing these parameters can cause the ballast to draw excessive current or to provide an unstable current to the lamp, either of which can lead to damage or failure. Operating the ballast at a different voltage than it was designed for can lead to several undesirable outcomes. Firstly, the ballast may simply fail to operate. The transformer may not be able to step up the voltage high enough to ignite the lamp, or the internal components may not function correctly at the new voltage level. Secondly, the ballast may be damaged. Applying the incorrect voltage can cause the transformer to overheat, the capacitor to fail, or the inductor to saturate. Any of these failures can render the ballast inoperable and could potentially create a safety hazard. Thirdly, the HPS lamp may not operate correctly. Even if the ballast is able to ignite the lamp, the voltage and current supplied to the lamp may not be optimal. This can result in reduced light output, flickering, or premature failure of the lamp. Additionally, the change in voltage and phase could lead to an imbalance in the power supply to the HPS lamp. The ballast is designed to provide a specific amount of power, 250 watts in this case, to the lamp. If the voltage and phase are changed, the ballast may not be able to deliver the correct amount of power. Too little power could result in a dim or non-functional lamp, while too much power could cause the lamp to overheat and fail prematurely. From a safety perspective, attempting to rewire the ballast in this way is highly discouraged. Electrical equipment is designed and tested to operate within specific voltage and current ranges, and any modifications outside of these ranges can create a safety hazard. Firstly, the risk of electrical shock is increased. If the ballast is not properly grounded or if the wiring is not done correctly, there is a risk of electrical shock to anyone who comes into contact with the equipment. Secondly, there is a risk of fire. Overheating components or faulty wiring can create a fire hazard. The ballast is typically enclosed in a metal case to contain any potential fires, but modifying the ballast can compromise this safety feature. Thirdly, the equipment may not be certified for use at the new voltage. Electrical equipment is typically certified by organizations such as Underwriters Laboratories, or ALL, to ensure that it meets certain safety standards. Modifying the equipment can void this certification and may violate local electrical codes. Considering these potential risks and problems, it is strongly recommended that you do not attempt to rewire the 277 volts 3-phase ballast to operate on a 120 volt single-phase service. Instead, you should use a ballast that is specifically designed for 120 volts single-phase operation. These ballasts are readily available and are designed to provide the correct voltage and current to the HPS lamp without any modifications. Using the correct ballasts will ensure safe and reliable operation of the HPS lighting system. You can find 120 volt single-phase ballasts at most electrical supply stores or online retailers. When selecting a ballast, be sure to choose one that is rated for the correct wattage of the HPS lamp. In this case, you would need a 120 volt single-phase 250 watt ballast. Also, Make sure that the ballast is UL certified or has equivalent safety certification. This will ensure that the ballast meets all applicable safety standards. If you're unsure about how to install the new ballast, it is always best to consult a qualified electrician. A licensed electrician will be able to safely and correctly install the ballast and ensure that the HBS lighting system operates properly. Remember that electrical work can be dangerous, and it is always best to err on the side of caution. Attempting to modify electrical equipment without the proper knowledge and experience can lead to serious injury or property damage. In summary, rewiring a 277 volts 3-phase HBS ballast to operate on a 120 volt single-phase service is not feasible or safe due to voltage and frequency design constraints, potential damage, safety hazards, and regulatory compliance. Always use appropriately rated equipment and seek professional help when dealing with electrical systems.